Good day everyone. Today I will discuss my project 1, which is the 7 segment decoder project. The description of this project was to create 3 7-segment decoder displays, 1 octal, 1 hexadecimal, and 1 binary coded decimal display. So the circuitry of these 3 displays will be shown using respective gate configurations and IC configurations. For the system design and hardware specification, this is the view of my whole circuitry. We have an octal, hexa, and BCD. So for the base of my circuit, the first part of the system design was building the octal circuitry. This was the base for all my circuits. This means that my hexa display and my BCD display was connected or was derived from the octa, and I just added some parts for the hexa and the BCD. So this was derived from the original hexadecimal arrangement provided by the project instructions. So from the original project, I extracted the first 8 from 0 to 7. So this was the truth table. And then I built a corresponding K-map for each segment. We have for segment A, 10110111. This is the K-map, and the corresponding Boolean expression was A, B, X NOR D plus C, which can be observed in this part. B, X NOR D plus C and A bar. This is AND gate towards A bar, towards the segment A of octal. Then for segment B, corresponding K-map for this value. And we have a Boolean expression of C, X NOR D or B bar, A bar. This is the corresponding circuitry. C, X NOR D or B bar, then end sa A bar towards the segment B of the octal. For the third, we have values of these values. Construct a K-map, then build the corresponding Boolean expression, which is B or C bar or D and A bar. B or C bar plus D and A bar. It's connected towards our C segment of the octal. And then we have for D, we have 10110110, constructed a key map and proceeded to get the overall Boolean expression, which is B NOR D, this part, plus B bar C, this part, then C X OR D, C X OR D, this part, or B, then all of them are gated towards each other. These are the OR gates, and AND gate towards the A bar. This is connected to the D segment of our display, which is this part, the D segment. It goes up. And for our E, we have a K-map 10100001. We have B bar, D bar plus C D bar and A bar. B bar, D bar plus C D bar and A bar towards our E segment over here. Then for our F K-map, we have 10001110, which is C NOR D, this part, plus C X OR D and gate towards C NOR D, tapos we have B, then C X OR D and gate towards A bar, this part, connected to our F segment. And for our G segment, we have C D bar, this part, C D bar, B X OR C, then OR gate towards our A bar and gate and towards the G segment. So that completed my octal display. What I did for the hexadecimal display was this. I used the pre-existing octal segments. So for the hex, this is the hex. I made use of the octal segments previously created and then connected another K-map or the second half of the K-map to form the hexadecimal logic gates. These were then created through a K-map. So the first half of my hexadecimal was this truth table from the octal, while the second half was formulated again starting from 8 to 15. For our hex A, we have C bar D plus B nor D, then end A. This is the circuit. Then for RB, before we proceed to RB, those circuitry, it needs to be OR gated towards the octal segment A, since I previously stated that the hexadecimal is just a combination of this new circuit plus the octal segment A. Then for our hexadecimal B, we have C bar D plus B nor D and A. This is the part. Then connected to the octal segment B again to create the hexadecimal key map. Then for segment C, we have B bar or C bar D. B bar or C bar D and A connected to the segment C of the octal towards the segment C of the hexadecimal. And then we have an A, and for the segment D, we have B XOR D plus C bar and A, which is this circuit right here. Again, these are connected to our segment D from octal towards the segment D for the hexadecimal. And then for E, we have B plus D bar plus C, E, B plus D bar plus C and A or segment E. For F, we have B bar plus D bar plus C and A towards segment F, this part. For the last, we have B bar plus D plus C and A towards segment G, this part. Then towards segment G, then OR from octal. So that completes my hexadecimal configuration. And for the last part, I had a BCD, a binary coded decimal of these parts for the BCD. For my binary coded decimal display, I used the pre-existing octal segments from A to G. Then I added the values for numbers 8 and 9. This corresponds the input for 8 and the input for 9. So I found out that 8 A, B, C, D, F, and G have the same circuitry that is to be added to the octal, which is 1, 1. And then the only different is the E, which is 1, 0. So for A, B, C, D, F, G, I have assigned this BCD added circuit 1 by BCD 1, and it had the value of A, B, C bar. For the BCD added circuit 2, it had the value of D bar and YBCD1, which means that its value is ABC bar D bar. So for my BCDA, segment A, I used BCD1, YBCD1, which is this part, and had it on an OR gate with the octal segment A. Octal segment A from previous configuration, which is here, octal segment A. This is the octal segment A. Then for the letter B of my segment, I added that YBCD1 circuit again, the added circuit towards B. Same goes for C, D, F, and G, where they have BCD1 plus corresponding octal segment. And for my E, I used the AND gate for YBCD2, which is D bar, and YBCD1, so that I can achieve a value of ABC bar D bar, and connected it to the segment E of my octal, which is in here. Segment E of octal, this wire here, and towards the segment E of the binary coded decimal. So for the whole experiment of my gates, I used 33 OR 2 input gates, 742N, 3 XNOR 2 input gates, 74LS266N is the name of the gate, then 26 and 2 input gates, namely 7408N, then 4 7486N XOR gates, 3 7402N NOR gates, and 4 7404N NOT gates. So to test if the circuit is working, we will try the values. We have 1, 2, 3, 4. 5, 6, 7, and we have an 8, an 8, we have a 9, we have a 10, we have an 11, we have a 12, a 13, a 12, 13, we have a 14 and a 15. So that's it for my gates. So I converted this into another circuit consisting only of IC gates, in which the same configuration and K-map was used from this system design, same process, and then the results were also the same inputs. So 1111 is F, we have 001 is 1, we have 0101 is a letter, is a number 5. So for this IC configuration, this circuitry, I used one NOT gate, one NOT IC, which has the name of 74LS04, then one XNOR with the name of 74LS266N, 9 OR 74LS32, 7 AND IC 74LS08, 1 NOR 74LS02, and 1 XOR 74LS86. Those are all my used gates for the IC, and that was my configuration, my K-map, my system design, and my hardware specifications for this project. Thank you for listening.